your graph, hopefully. And then we're going to talk about function notation. So, here we go. Before we can even talk about functions, we need to talk about what a relation is. If you think about a relationship, maybe you're in a relationship, I don't know. But we talk about a relation as a graph. I'm going to turn that fan on if it gets too much. You guys turn it off. We're talking about a set of pairs of input and output values. So those scatter plots that we were making before would all be relations, because it's just a bunch of points on a graph. What gets different between a relation and a function is we need to specifically look at those points and see if they have one key factor. Okay? So everything we deal with is a relation. Everything we deal with is not necessarily a function. But usually, for the most part, it is going to be a function until we start getting into inverses of each other. All right, so if I needed to graph this relation, would you be able to do it? I don't even know if you need to put this in your notes. Can you plot this? Yeah. Negative 2, 4. Where does it go? Negative 2, 4. Where does 3, negative 2 go? Over 3, down 2. Well, negative 1, 0. 1, 5. All right. That's a relation. Plot at some points. Does it look like there's a correlation between those points? No. Not really. I mean, this is going up, that's going down. I would say that there is no correlation. If we put those points into our calculator, what do you think our correlation coefficient would be? Pretty darn close to 0, right? Now I'm curious, now that I asked you guys. I'll figure it out, don't worry. Give me 2 seconds. So what is it? Negative 2, 3, negative 1, 1, 4, negative 2, 0, 5. Stat, calculate, linear regression. Our R is at, really negative 0.49. I might have some things going on here. Let's try this again. Calculate. Negative 0.489. So that's about negative 0.5. So it's saying it has a negative correlation. It's about halfway. So it wasn't as close to 0 as we thought it was. Anyways, okay, can you do that? Yes? Can you plot points? Hopefully. Okay. Can we identify a domain? Well, what is domain? Remember, domain is the set of all your inputs. Or if you want to think about it, it's just your x coordinates of your ordered pair. So domain is the set of all inputs So if we think about the set that we just had, so we had negative 2, 4, 3, negative 2, negative 1, 0, 1, and 5. Those were the set of my numbers for my relation. What would be the domain? What numbers are in the domain? Yeah, and usually you go smallest to largest. So my smallest is negative 2, then negative 1, then 1, and then 3. So my domain in that previous example would be the values negative 2, negative 1, 1, 3. These little braces, that just stands for the set of numbers. We're talking about a set of numbers. I just put the braces around because it's a set notation. Okay, when you get into pre-calc or advanced algebra next year, you're going to be writing stuff in set notation. Okay, so then what would the range be? What would be our definition for a range, I guess is what I'm asking. The set of all output values, or the y coordinates of the ordered pairs. So if we were looking at this same set of numbers, so -2, 4, 3, -2, -1, 0, 1, 5. Oops, what's that parenthesis? We already said that our domain is the set of -2, -1, 1, and 3. What would be the range? Yeah, I go smallest, so -2, 0, 4, 5. Your numbers do not need to match up. Like this input does not need to match up with this output. Just put your numbers from smallest to largest. Okay, so domain is all of your x values. Range is all of your y values. So from asking for a domain, that's what you're giving me. If I'm asking for a range, that's what you're going to give me. Okay, so given a relation, can you plot it? Yes. Given a relation, can you identify the domain and the range? Yep. Okay, good. So far, so good. Yes? Okay. All right, we already did that. So, what makes a function and not a relation? Well, every relation is a function, but not every function is a relation. So our definition of a function is a relation in which each element of the domain is paired with exactly one element in the range. So if we look at this previous relation that we had up here, look at all of your x values. I've got a -2, I've got a 3, I've got a -1, and I've got a 1. Are any of those x values being paired with a different y value? Like, is there, like right now, -2 is paired with 4. Is -2 paired with any other number in this set of ordered pairs? No. Here, 3 is paired with -2. Is 3 paired with any other y value besides -2? No. Here, -1 is paired with 0. Is -1 paired with any other y value? No. Here, 1 is paired with 5. Is it paired with anything else? No. So this would be an example of a function. All right, so let's look at some examples. Here's a table of values. So just make a quick XY table. I don't know why there's not a line going through this. Under your x coordinates, you have the points 1, 2, 3, 4, 5, 6, and then 52 in there for fun measure. Under your y, we have -3.6, another -3.6, 4.2, 4.2, 10.7, 12.1, and 52. And the question is this a function? Well, we already know how to tell whether something is linear or not. We can decide whether something is a linear function by checking the change in the y and checking the change in the x and make sure those are both constant. Okay, we could check to see if it's direct variation by taking our ratio y over x and see if those end up being a constant of variation. But all I want to do right now is just decide, is it a function? I don't care if it's linear. I don't care if it's quadratic. I don't care if it's cubic. I just want to know, is it a function? What do you guys think? Raise your hand if you think yes. Raise your hand if you think no. Okay. Those who have said no, why do you think it's no?
Because -3.6 and -1.6 show
Okay, so let's go back. Thanks for volunteering. A relation in which each element of the domain, so that means the x or the y. Yes. That means the x, is paired with exactly one element in the range, which means y. So let's look here. Look at my x. Is 1 paired with negative 3.6? Yes. Is 1 paired with any of these other numbers? No. So what we're looking for is multiple x's instead of multiple y's, right? So since I don't have any repeats in my x's, this would be a function. So this is a function. Yes, function. Okay. If I were to change this problem and turn that 2 into a, well, that would just be the same problem. Let's change this 3 into a 1. So if I changed this value here to a 1, so this changes to a 1, now I have 1 being paired up with negative 3.6. But now I also have 1 being paired up with 4.2, which can't happen. So that would make it not be a function. You see the difference? So ultimately, you're looking for only one x value for each number, not multiple x values of each number. If I changed all of these to 1s, then it definitely would not be a function. Because then 1's got 1, 2, 3, 4, 5, 6 different pairings going on. Okay? So, someone repeat what I just said. How do we determine whether something is a function given a table of values?
Is paired up with any other y again?
Right. So x can only have one match. It can't have multiple matches. Does that make sense? Okay, so another way we can determine whether a function is, or a relation is a function, is called the vertical line test. You guys remember the vertical line test? I know it's been a while since Algebra 1 days. So a vertical line test sounds exactly like what it is. You take a vertical line, and you put it on top of a graph, and that is used to test whether a relation is a function or not. So let me step back here a second. So far, if I give you a relation, negative 3, 4, negative 5, 6. Is that a function? Yes. What if I said negative 3, 4, negative 3, 6? Is that a function? No. Okay, so given a set of numbers, you should be able to determine whether we have a function. Given a table of values, is that a function? Yes. What if I add it that point? Now is it a function? No. So given a set of ordered pairs, given a table of values, you should be able to identify whether a relation is a function or not. So now we're going to look at is, if given a graph, how do you determine whether something is a function or not? So let's put a few little graphs down here. First graph, absolute value, makes a V. For that to pass the vertical line test, I need to be able to make as many vertical lines as I possibly can imagine. Do any of these vertical lines intersect my graph in more than one spot? Nope, this line's only intersecting at one spot, intersecting at one spot, one spot, one spot, one spot, one spot, one spot. Is there any other fathomable vertical line that would intersect that graph in more than one spot? No. So because it won't, that means that it is a function. Okay, let's look at another graph. Let's make a quick sketch of the inverse of a quadratic. Makes kind of a C. Would that graph pass the vertical line test? No, because if I make one vertical line right there, all I need is just one vertical line that makes the vertical line test fail for it to not be a function. Okay. What if I gave you a scatter plot of graphs? So here's our graph. Here's a dot. Here's a dot. Here's a dot. Here's a dot. Would this be a function?
No.
No. What two points are vertically above each other? The first two, right? So again, I only need one vertical line to intersect in more than two spots of my relation for it to not be a function. Okay? Questions with the vertical line test? Pretty simple, right? So you're just looking for vertical lines. All right, so to determine whether a relation is a function, we're looking for either multiple x values on either the ordered pairs or the table. We're looking for a graph to pass the vertical line test. So now, let's go here. Let's take a graph and identify the function. Here, I'm not going to make you redo this one. Let's just make up one here really quickly. Make a quick graph of a coordinate plane. Go 5 units in all directions. And then let's plot a point at -4, +4. I'm going to label it for our own benefit. Let's plot a point at -2, -3. Or -2, +3, sorry. My bad. Let's plot a point at 1, 1. Let's plot a point at 4, 0. From that graph, can you identify the domain and can you identify the range? Avery, what's the domain?
-4, -2, 1, 4.
1 and 4. So the set of -4, -2, 1, and 4. Can you identify the range? Go for it, Avery.
0, 1, 3, 4.
Good. Okay, so the only thing that might change is on the homework. They might not give you these ordered pairs. You're just going to have to find the ordered pairs. Now, I want you to take notice. How did we work the domain? Keeping in mind, domain, when we list our numbers, should go smallest to largest. So what direction should we be starting in when I start identifying my domain? Left and go right. Range, we want to go from smallest to largest. So what direction should I be starting and going to? Well, not necessarily right to left. Bottom to top. Remember, range is your change or your y. Domain are your x coordinates. So x, you should be going from left to right. Range, you should be going from bottom to top. So now what happens if I give you something like this? Make another quick graph. Go out 5 units. All right, so now let's say that we have, what is that, -4, +3. Then put a point at 0, 0. And then put a point at 4, +3. And then connect those with a line. how would I figure out the domain and the range of that?
Figure out the points.
Well, how many points are on there? Are you sure?
There's an eternity.
An eternity. There's an infinite, right? Infinite amount of points on there. I can't just use nice whole numbers or integers. I mean, probably, let's say, negative 3.999999999, comma 2.999999999 is on there. And then I could take away a 9 from each of those, right? We don't want to list every single one of those. So how do we write that? Domain. Work left to right. What's the furthest left x value on my graph? Negative 4, right? Leave a gap. What's my furthest right value on that graph for my x? 4. X represents the x or the y values. X, right? So right now, my x values are between negative 4 and 4. Yes? How do we write that as an inequality? Ben?
It would be negative 4 is, or like x is greater than negative 4, or greater than or equal to.
Yeah.
And then x is less than or equal to.
Yeah, remember looking at these compound inequalities before in your life? Okay. So our domain are all values of x between and including negative 4 and positive 4. So what would that look like as a range? Range, what would be the variable in between? Y. Now remember, with the range, we said we go from bottom to top. What's my lowest y coordinate? 0. What's my highest y coordinate? 3. Good. Okay. So see if you can do this one on your own. Make a quick graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm just going to give you 1, 2 as one of your points. And negative 3, negative 4. Straight line. So negative 3, negative 4. And that point is 1, comma 2. Identify the domain, identify the range. Farthest left x is negative 3. Farthest right x is 1. Good. Bottom y is negative 4. Top y is 2. Good. Okay. Now you're ready for this. Jason says no. What would happen if on that graph I took away that top point and had it go on and on and on forever?
You wouldn't have the second. Would it just be infinity?
So it's going on till infinity, but we're not going to put an infinity sign there.
Right.
So what are we going to say?
So just It's more than the...
Yeah, can we just say x is greater than negative 3?
Yeah.
Yeah, we could, huh?
Oh.
Which I'm just going to rewrite it as x is greater than negative 3, because usually you put your variables first. That's okay if you don't. Well, what happened with my range? What did I get rid of?
The -4 or the 2.
The 2, because I don't have a top half anymore, right?
Right.
So we're just left with y is greater than or equal to negative 4. Are you ready for this craziness? What if I took away the bottom ending point?
You wouldn't do that.
Yeah, so now do I have a bottom point on my left side? Or do I have a furthest left and furthest right?
It would be like...
So now I'm going to get rid of that.
Just say X.
Well, I have to put something there.
All real numbers.
All real numbers. What's my range going to now be? All real numbers. Okay. Isn't that cool?
No.
What would be, if I turn that into a continuous graph all the way through, what would change in my domain?
Yeah, it would
Do I
be
have
all
a
real
left
numbers.
or a right anymore?
No.
So my domain would go to what?
All real numbers.
All real numbers. What would my range go to?
It would be greater than 0, or greater or equal to 0.
Right, so I'm just going to get rid of the top, right? Because I no longer have a top ending
Right.
point. But I still do have a bottom ending point, so it would be everything y greater than or equal to 0. See how that works? Okay, so given ordered pairs, given a table, you can identify whether it's a function, yes? Given a graph, you can identify if it's a function using your vertical line test? Yes. Given a graph, can you identify the domain and the range? Hopefully. The last thing we have to cover is function notation. Let's just get right to the example here. So usually, this is the last thing we're doing, right here. Last thing. Usually when you're dealing with functions, you write answers in function notation. And usually function notation looks like f of something. So if I had f of x, the way I would read that is f of x. It's not f times x, it's f of x. It's your function notation. So if I give you a function f, this could be g, this could be h, this could be r, this could be s. I could have function t if I want it. But right now we have function f. Right now function f is the expression 3x minus 5. Whatever is inside the parentheses usually identifies the variable. So if I were to change this to f of t, what would my expression change to? Don't put this on your notes. It would be 3t minus 5, right? If it was f of n, then it would be 3n minus 5, okay? So this identifies the function, this identifies the variable for your expression. This is no different than just y equals. Y and f of x are the same thing. So if I wanted to evaluate function f for the x value of -3, that -3 now becomes my input value into the function, which means I'm going to change my x to a -3 minus 5. So if I were to input -3 into x, what would be my output? -9 minus 5,
-14.
-14. So f of -3 is equal to -14 would be a solid answer. So what this is telling me is I evaluated function f for x being -3, and when I put in -3 for x, my output ended up being -14. You guys remember doing this? Algebra 1. So if I wanted to do f of 0, what would be my output? -5. If I wanted to do f of 5, what would be my output?
5, 10,
10, 15, 20. Okay? So, function notation. So that's everything you've got for section 3.